All right, so this video is basically how to apply inverse or reciprocal functions of trig functions in right triangles. If you're like, what? I don't know what CSE stands for. You should probably watch my other video where I kind of talk about where it comes from and how it works. I'm going to do a little bit of that here in this video, but just in case you need a kind of deeper explanation, I did another video basically introing this. So this is the way I like to solve triangles like this. So it wants to know what cosecant of theta is. So theta's up here. Okay, so theta's up here. And let's go ahead and label our sides. So I still pick an angle. I'm still going to label all my sides. So farthest away from theta is the opposite. 7 is the adjacent. And 25 is the hypotenuse. Okay. So that's all. They're all labeled there. And we have to know that CSE is cosecant, okay? So cosecant, and it's reciprocal because the best way to kind of explain how to do it, rather than memorizing 6 different ratios, memorize the base 3 ratios. So if you remember sine, cosine, and tangent, you will know you'll know how to do and explain how to find secant, cosecant, cotangent. Okay, so the inverse of cosecant is sine. So if I find sine of theta, then I can just flip it over to find cosecant. So if I find sine of theta, just flip it over, and then I'll have cosecant. So to find sine of theta, isn't that opposite over hypotenuse, right? That's how I find sine. And then, once I find sine, I'm going to flip it over to get cosecant. But notice how in this triangle, I am missing the opposite. I don't know what that is. So I need to find it before I can do this problem. All right, so it's a right triangle. That means we can do Pythagorean theorem. Yay! 7 squared plus b squared is what we'll call it, equals 25 squared. Okay, so 7 squared is 49 plus b squared, and 25 squared is 625. Subtract 49. B squared equals 576. Square root of that, hey, it's 24. Cool. All right, so the opposite side equals 24. All right, now that I know the opposite side, I can now figure out what sine is. And remember, the whole goal is, once I find sine, I need to flip it over to get cosecant. All right, so sine equals 24 over 25. But to get cosecant of theta, these need to switch spots here. So that equals 25 over 24. So 25 over 24. Okay? So, again, what's crucial in the beginning is when you see a reciprocal identity, a cosecant, cotangent, or secant, flip it over to its original, either sine, cosine, or tangent. Make sure you find that, and at the end, just flip it back over. You can, I mean, there's nothing wrong with memorizing that cosecant is actually hypotenuse over opposite, but rather than remembering that, I just remember SOHCAHTOA, and SOHCAHTOA is what I know the best, and so I just know that the reciprocal of cosecant is sine, find sine, then go back. That's what I like to do, and that's how I'd encourage you to do it. Okay, so that's one problem. Let's do one more example together here. All right, here we go. So now secant. So if you look back in your notes, or if you remember, so the way I like to kind of go through this, so secant. Secant is missing a co. So I know that the reciprocal of secant will be cos something, and it's actually going to be cosine. So cosine of theta is the reciprocal. Okay, and then using SOHCAHTOA, I know cosine is adjacent over hypotenuse. Okay. So secant is actually going to be hypotenuse over adjacent. Okay? So let's make sure we have what we need here. So there's my angle. Let's label the sides. Farthest away is opposite. The 11's hypotenuse because it's opposite of the 90-degree angle. And 4 radical 7 is the adjacent. Hey, we have it. Cool. Let's go ahead and write it. So 4 radical 7 over 11. Awesome. But remember, I don't want cosine. I need secant. So that means these need to switch spots on me here. So secant of theta equals 11 over 4 radical 7. which hopefully a buzzer goes off in your mind. Mr. Schwant, we can't have radicals in the denominator. So, the same trick we learned, rationalization, multiply by radical 7 both top and bottom, multiply straight across, which gives us 11 radical 7 over 4 radical 49. So remember, when you're multiplying with radicals, if there's numbers in front and a radical, just sandwich them together. There's nothing you can do. But if two numbers are inside of square root or a radical, you can multiply those together. And then radical 49 equals 7. So 4 times 7 actually equals 28. So that is what secant equals. Secant of theta equals 11 radical 7 all over 28. Okay? So that is how you use reciprocal functions within right triangles. Again, just be careful to make sure there's no radicals in the denominator. And again, following my advice, I would recommend knowing the reciprocals. So change it to one of the basics, so sine, cosine, tangent. Find out what that is, and at the end, flip it over.